Continuing on with looking at geometric sequences, we have a couple of problems here that we're going to work through. And we might work them a couple different ways, so just know that going in. You'll see some different ways to work these. So as I look at problem number 3, it says find the explicit formula. So there's a whole lot of ways that we can write the explicit formula for this. We just learned about that. And we can use any of these that we would like. So we'll start by knowing that term 1 is -4. So that's actually a point that would be on our graph if we were to graph this sequence. And if you look, we can see that R is -2. So I know that to find any term, I can take the first term and I will multiply it by my common ratio n minus 1 times. So if I want to find the third term, that means I will multiply by R 2 times. That's how I get my exponent of 3 minus 1 or 2. I could use the fact that the point 432 would be on this function. And so if I want to find a sub n, I would take 32 and multiply it by our common ratio n minus 4 times. So for example, if I want to find -64, I would take 32 and multiply it by -2 once. Well, what term is -64? It's the 5th term. So if I plug 5 into this equation, 5 minus 4 is 1. Hence, I'm taking 32 and multiplying it by -2 once. So, I mean, any of these would be correct answers. So, actually, I could write this an infinite number of times, and they all be equivalent. So next, as I look at the recursive formula, remember the recursive formula, I need a place to start. And I'm saying to find a sub n, what am I doing to the previous term every single time? Well, in this problem, I'm multiplying by -2. And let's find a of 25. So I obviously do not want to use the recursive formula, because if I want to find the 25th term, according to the recursive formula, I would have to know the 24th term, which means I would have to know the 23rd term. And I definitely don't want to have to write this out until term 25. So instead, I'm going to use the explicit formula. So 32, well, I can go back and use the first one. It doesn't really matter. I could use any of these. I'm going to get the same answer. So I would take -4 times -2 to the 25th minus 1. So that would be -4 times -2 to the 24th. Now you might say, oh my goodness, I'm going to type this in my calculator. That's fine. You certainly can. If this were on a test or quiz and you don't have a calculator, I would in no means expect you to know what -2 to the 24th is, or figure it out. So you could actually leave your answer as you see here. But I have typed this final statement into my calculator. And there we go. Now, what you might want to do at this time is pause this video, work these next couple problems, and then start it back and see what you get. Okay, so I would stop the video, work 4, 5, and 6, and after you finish those, start it back up. All right, you guys should have had some time to stop your video. Let's go look at problem number 4. So the first thing becomes, what are we multiplying by every single time? So first I see 10 to the -3, and I want to remind you what this means. Do you guys remember what a negative exponent means? It actually sends that to the denominator. So 10 to the -3 is the same as 1 over 10 cubed. And 1 over 10 cubed is 1 over 1,000. And then 10 to the -1 is really 1 over 10. And then 10, and then 10 cubed, and then 10 to the 5th. So what are we multiplying by every single time? What's our common ratio? Well, I'm going to start here. If I have 10 and I want to get to 10 cubed, I'm going to be multiplying by 10 squared. That's my common ratio. And I can leave that as 10 squared, or I can certainly write it as 100, either one. So for my explicit formula, I want to remind you there's a lot of different ways we can write it. Let's use the fact that the first point is negative 1, or excuse me, 1 and 10 to the negative 3. So that would mean a of n. I'm going to take the first term and multiply it by my common ratio, n minus 1 times. Now there is some manipulation you can do to this equation. I know that if I have a power raised to a power, I could multiply, so I could certainly write that as 10 to the negative 3 times 10 to the 2n minus 2. I don't have to. I could leave it the original. I could actually, these have common bases. So if you're multiplying exponents that have common bases, you can add your exponents. So I could have 10 to the 2n minus 5, negative 3 and a negative 2 that add to give me a negative 5. So I mean, I have a whole lot of different ways that I could write this explicit formula. I'm just going to stick to using the one that we found before. So let's actually find a to the 16. A to the 16 will equal negative 10 to the negative 3 times your common ratio, 16 minus 1. So I get 10 to the negative 3, 10 squared to the 15th. A power raised to a power, I get 10 to the negative 3 times, pencil broke, 10 to the 30th. I am multiplying like bases, which means I add my exponents. So when I add those exponents, I get 10 to the 27th. And I am not going to type that in my calculator. That's going to be a huge number. And for our recursive formula, let's actually use that the second term is 10 to the negative 1. So I know that a sub 2 is 10 to the negative 1, gives me a place to start. And to find a sub n, I will take the previous term and I'm multiplying it by 10 squared. And again, you can write that as 100 if you want to. All right, two more to take a look at here. So what would R be in number 5? So we can take 250 and divide it by 100. And when we do, we see that R is 5/2. Let's use the fact that the first term is 100. So one of our explicit formulas could be we're taking 100 and multiplying it by R n minus 1 times to find a term. We could say that we're taking 250 and multiplying it by R n minus 2 times. Again, there's a whole lot of different ones we can use here. As I look at recursive, the first term is 100. And to find a previous, I need to take a previous term and multiply it by 5/2. That's how I'll get an a sub n. Here, it wouldn't be terrible to use the recursive formula. I mean, you've got 1, 2, 3, you've got 4 terms already. So you could carry that pattern out until you find the 8th term. I like to use the explicit, so I'm using good notation here. A sub 8 will be 100 times 5 over 2 to the 8 minus 1. So 100 times 5 over 2 to the 7th. And no, I wouldn't expect you to know what 5 over 2 to the 7th is. You should know 2 to the 7th. You should know that 2 to the 7th is 128. But 5 to the 7th, not something I would expect you to know. I have typed that into my calculator. My pencil keeps breaking. Then I went ahead and did type in 100 times 78,125 over 128, and it gave me a decimal. Now, one tip about decimals in math, you always want to round to 3 decimal places. Always. Okay, so always round to 3 decimal places. All right, let's look at our last one here. So if I take a term and I divide it by its previous term, I can see that R is 1 over X. So one of my explicit formulas could be I'm taking the first term and multiplying it by 1 over X to the n minus 1 times. And again, that's using the fact that term 1 is X. The recursive formula, I know to find a term, I need to take the previous term and multiply it by 1 over x, but I have to have a place to start. I have to know what I'm going to multiply 1 over x by, and again, it doesn't have to be term 1. I could give the fact that term 2 has a value of 1. And let's find a of 11. So to find a of 11, I'll take x times 1 over x to the 11 minus 1 times, which would mean x times 1 over x to the 10th. I would be perfectly fine with that answer, but since we're here, let's talk about a little bit of algebraic manipulation. This is x. What's 1 to the 10th? It's 1. What's 10x to the 10th? In order to multiply fractions, I multiply across. X times 1 is x. 1 times x to the 10th is x to the 10th. This is actually a fraction I can reduce. They share 1x. So in the numerator, I would have 1, and the denominator, I would have x to the 9th. Again, I would be okay with you leaving your answer as this right now. But this is a great multiple choice question in that your final answer is written like this answer. So if you have to know how to manipulate it to get to the answer that you're at. So that finishes our second video for this set of notes, and I will see you on our live tomorrow.